Welcome to the Public Exam Review for Unit 9, Chapter 11 on Permutations, Combinations, and the Binomial Theorem. In this presentation, we will look at permutations with and without repetition. Here we will focus on determining the number of permutations of n elements taken r at a time using a variety of strategies. We will solve counting problems when two or more elements are identical. A permutation is an ordered arrangement of all or part of a set. The order in which a number of objects is selected from a larger group of objects is important. We have this formula where we have n permute r is equal to n factorial divided by n minus r factorial, where n belongs to the set of natural numbers. The n permute r represents the number of permutations or arrangements of r objects taken from a set of n distinct objects in a specific order. It is also important to note right now that n has to be greater than or equal to r, which has to be greater than or equal to 0. If we are asked to evaluate 3 permute 2, that can be done algebraically by taking 3 factorial and dividing it by 3 minus 2 factorial. 3 factorial is equal to 3 multiplied by 2 multiplied by 1 divided by 1 factorial, which is just equal to 1. So 3 times 2 times 1 is equal to 6 divided by 1. So we have 6 different arrangements or 6 different permutations. Recall from a previous presentation that a factorial is an abbreviation for the product of successive positive natural numbers, and that n factorial is equal to n multiplied by n minus 1 times n minus 2 times n minus 3, and so on until we get to 3 times 2 times 1, where n belongs to the set of natural numbers. At this point in time, I would like to do a calculator demonstration of how you can use your graphing calculator, namely a TI-83, for which you could calculate 3 permute 2. So I will share my calculator with you. So if you want to calculate 3 permute 2 with the calculator, you simply type in 3, you go to the math button, you scroll over to probability, and you go down to where it says n permute r. You press enter, and then you press the number 2, in which you select 2 objects from a set of 3 objects. When you press enter, your answer is 6. So the calculator will give you the actual permutation when you substitute these numbers into the calculator. Let's return to our screen. So you can do it algebraically if you have small numbers in which you can work with. But for larger numbers, you're probably better off using the graphing calculator. A permutation in which you have a set of n objects with one object repeated a times, another object repeated b times, another object repeated c times, etc. It can be arranged in n factorial divided by a factorial, b factorial, c factorial ways. The following example illustrates the way in which the repetition of a letter can be calculated. So how many different 4-letter arrangements or permutations are there of the word pool? Note that the letter O is repeated 2 times. So there are 2 identical letters, but if they were different, they could be arranged in 2 different ways. So in this case, the letter pool can be written as P-O-O-L with the orange and the blue letter, but if the blue and the orange were arranged differently, you'd have the blue and then the orange written differently. Notice that altogether, there are 24 different possible 4-letter arrangements. That is equal to 4 factorial, which is equal to 24. But because there are 2 identical letters, they can be arranged in 2 different ways. So 2 factorial is equal to 2. So the number of 4-letter arrangements possible when 2 of the letters are the same can be given by 4 factorial divided by 2 factorial. 4 factorial is 4 times 3 times 2 times 1, which is 24, divided by 2 factorial, which is equal to 2. And 24 divided by 2 is equal to 12. So you can see the 12 different arrangements in the word pool. Let's look at some examples. If 5 books must be read from a list of 12 books provided, how many ways can this be done if the order in which you read the books is significant? So we are told that the order in which you read the books is significant. So this must be dealing with a permutation as opposed to a combination. So in this case here, we would have a set of 12 books, and we will permute 5 of them. So in order to calculate this, we will use the formula 12 factorial divided by 12 minus 5 factorial. That is equal to 12 factorial divided by 7 factorial. So this answer corresponds to C as the multiple choice answer. You have to identify the variables, and the formula that you will use here would be n permute r, which is equal to n factorial divided by n minus r factorial. You should also note at this time that this formula will be provided for you on the public exam. So when you're reading the question itself, you need to identify what the variables represent. So you have a list of 12 books provided. That tells us that the value of n is going to equal 12. And 5 books must be read. So that part of the statement tells us that the value of r is equal to 5. 5 items must be selected from a set of 12 items. In example 2, we are asked how many different 8-letter arrangements are there for the word calculus. So again, when we look at the number of letters in the word calculus, we have a total of 8 letters. N is equal to 8 altogether. And you can also notice there that we have repetitions. We have the letter C is there 2 times. You have the letter L is there 2 times. And we have the letter U there 2 times as well. So the number of different arrangements that we can have here would be given by 8 factorial divided by 2 factorial multiplied by 2 factorial multiplied by 2 factorial. When we calculate that, 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. And we can stop there because of the 2 factorial in the denominator. So then the other 2 factorial can be written as 2 times 1, and the other 2 factorial can be written as 2 times 1. Notice here that the 2 factorials will cancel. So then when you calculate this, using your calculator of course, you will get the product of 8 times 7 times 6 times 5 times 4 times 3 is 20,160. Divided by 2 times 2, which is equal to 4. So in this example, we have 5,040 different arrangements. So we have basically 5,040 represents the number of arrangements when 3 letters are each repeated twice. In example 3, in the grid below, a person must travel from A to B by only heading east or south, which represents the total number of possible routes that can be taken to get from A to B. So we are looking at the total number of possible routes. Let's look at one particular route as an example. So if I begin at A and I'm only able to travel east, you could travel east, which will be represented by E, east again, and then you could travel south, and then south again in order to get to B. So this is a case of a permutation involving repetition again. So you can see here that altogether, no matter what path you choose, you will have to travel east 3 times and south twice. N is equal to a total of 5, and you can see there that this one involves repetitions because E is there 3 times and S is there 2 times. So if we are to calculate the number of permutations possible here, we can calculate that by taking 5 factorial and dividing it by 3 factorial, 2 factorial. This answer corresponds with A as the multiple choice item. In actual fact, we can continue to compute this. 5 factorial is equal to 5 times 4 times 3 factorial. And we can stop there because there's a 3 factorial in your denominator. So we have 3 factorial multiplied by 2 multiplied by 1. So notice again that the 3 factorials here will cancel. And then on top we are left with 5 times 4, which is equal to 20, divided by 2. So we have a total of 10 possible routes that we can use to get from A to B. I just chose one example there, but I'd like to show you another one as well. If I begin at A and I travel east, and then I go south, then I travel east again. Then I could travel south, and then I go east again. Notice that you still have N equals 5, because you're going to travel east 3 times and south twice. So the repetitions are also the same. So that will be the case no matter what path or what route you choose to take. Let's look at another example. A code consists of 3 letters chosen from A to Z and 3 digits chosen from 0 to 9, with no repetitions of letters or numbers. Algebraically determine the number of possible codes that can be found. It is important here to notice that there are no repetition of letters or numbers. So when you look at the letters that are chosen from A to Z, note that there are 26 letters of the alphabet from A to Z, and the digits are chosen from 0 to 9. Notice here that we have 10 possible digits from which we can choose. So in this case here, if we write it as a permutation, we have 26 letters, and from them we will permute 3. Using the fundamental counting principle, we will multiply that by the number of possible digits. So we will have a total of 10 digits, and we will permute 3 of those from that 10. You multiply these together, and this would be a calculator exercise again. Okay, so we can do this using the calculator. I will share the calculator with you again. So in this case, we will see, first of all, you have 26. Go to Math, go over to Probability, down to a permutation, and we will permute 3. Press Enter, and the total number of permutations is 15,600. As well, we will multiply that by the number of permutations. We have 10, and we will permute 3 out of those 10. And then you will have a total of 11,232,000 different possible codes. Let's go back to the screen, and we'll write in these answers as part of our solution. So you can use your calculator, and I think that that is the easiest way to do the calculation, but we will also do it manually in a minute. So that would be 15,600 different permutations for which we can select the 3 letters from A to Z. There are 720 possible ways in which we can select 3 digits from a set of 10. 15,000 multiplied by 720 is equal to 11,232,000 possible codes. You can also use factorial representation of this information as well. 26 permute 3 can be written as 26 factorial divided by 26 minus 3 factorial, multiplied by 10 factorial divided by 10 minus 3 factorial. That simplifies to be 26 factorial divided by 23 factorial multiplied by 10 factorial over 7 factorial. So again, we can multiply this as follows. 26 factorial is the same as 26 times 25 times 24 times 23 factorial divided by 23 factorial. And on the other side, we have 10 factorial can be written as 10 times 9 times 8 times 7 factorial. We'll stop there because of the 7 factorial in the denominator. Notice that we could cancel 23 factorials and the 7 factorials, and when you multiply 26 times 25 times 24 times 10 times 9 times 8, you still get 11,232,000 different codes. In example 5, how many more distinct 5-letter arrangements can be made from the word great than the word greet? So let's look at the letters in the word great. In this case here, you should notice that the value of n will equal 5 because you have 5 letters in the word, but there are no repetitions. So this is simply a situation where we have 5 letters from which we have to permute 5. So that is equal to 5 factorial divided by 5 minus 5 factorial. So we have 5 factorial divided by 0 factorial. So that's equal to 5 times 4 times 3 times 2 times 1. And 1 factorial is just equal to 1. So that will equal 120 different 5-letter arrangements. And there are no repetitions there. However, in the word greet, notice again that we have n equals 5 because there are a total of 5 letters in which we can choose. However, this time we do have repetition because the letter E occurs 2 times. So that means that the letter E can be written in 2 different ways. So in order to calculate the number of permutations here, we will use 5 factorial divided by 2 factorial. That's equal to 5 times 4 times 3 times 2 factorial divided by 2 factorial. The 2 factorials will cancel. And 5 times 4 times 3 is equal to 60. So in this case here, because we have repetition, there are just 60 different possible arrangements. So then how many more 5-letter arrangements can be made from the word great than the word greet? We can simply answer that question by taking 120 and subtracting 60, so there would be 60 more different 5-letter arrangements from the word great than the word greet. And finally, in the last example, we have 4 students are selected from a group of n students to fill the positions of president, vice president, treasurer, and secretary on student council. If there are 360 different ways this can be accomplished, how many students are there to select from? So this would be a typical long answer question that you could be asked on your public exam. Notice in this case, we are asked to determine the value of n, which represents the number of students from which we have, the total number of students from which we can select. So let's look at some key pieces of information. We are told that 4 students are selected from a group of n students, and we are filling the positions of president, vice president, treasurer, and secretary. So because in this case, you can see there that order matters. So this is an example of a permutation in which we have n number of students from which we have to permute 4. And we are told that there are 360 different ways in which this can be accomplished. So let's convert this to factorial notation. N permute 4 can be written as n factorial divided by n minus 4 factorial is equal to 360. N factorial is the same as n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. We can stop there because of the n minus 4 factorial in the denominator. That is all equal to 360. So notice here that the n minus 4 factorials will cancel. So now what we have is n multiplied by n minus 1 times n minus 2 times n minus 3 is equal to 360. In order to solve for n, you can multiply all this out, but I think that that's a time-consuming technique. It is important at this stage of the game to look at restrictions that must exist for the variable n. Notice when you're working with the permutation that n must be greater than or equal to r, which must be greater than or equal to 0. That is very important to remember. So in this example, n has to be greater than or equal to 4. So using this piece of information, we can begin to let n equals 4 and substitute values by multiplying these 4 numbers to see if we could get a product of 360. So if we begin with n equals 4, then we would have 4 multiplied by 3 multiplied by 2 multiplied by 1. And the product of these 4 numbers is equal to 24. So n equals 4 is not a legitimate solution because we are looking for the product of these 4 numbers to equal 360. So then we check n equals 5 because n does have to be a natural number. So then we would have 5 multiplied by 4 multiplied by 3 multiplied by 2. The product of these 4 numbers is equal to 120. Therefore, n equals 5 is not a possible solution. Let's check n equals 6. So we would have 6 times 5 times 4 times 3. And the product of these 4 numbers is equal to 360. So using trial and error here, we know that the value of n must equal 6. So we had 6 students from which we could choose 4 for the positions of president, vice president, treasurer, and secretary. A permutation, then, is an arrangement of objects in a definite order. The number of permutations of n objects taken r at a time is given by this formula, where n permute r is equal to n factorial divided by n minus r factorial. A set of n objects containing A identical objects of one kind, B identical objects of another kind, and so on, can be arranged in n factorial divided by A factorial, B factorial ways. So in the first instance here, we have no repetition. So this first formula will be a situation that involves permutations without repetition. In the second case, we do have identical objects of another kind. So this formula here is what you would use when you do have repetition. Thank you for your time and your attention. As we continue with the review, we will look at permutations that involve restrictions or constraints.